Hi everyone, this is Davide. I'm an Adobe Express. Hi everyone, this is Davide. I'm an Adobe Extensibility developer and author from Italy. I've just wrapped up recording a tutorial on Adobe Express add-ons development leveraging the latest Document Sandbox API. All it takes is an Adobe ID, which I suspect you already have, it's free by the way, and some JavaScript knowledge. Not that much, to be honest, and you'll be able to build products ready to be featured on the new Adobe Express add-ons marketplace. Cool! You ready? Go watch it. I'll wait here. Okay, to start, let's get to the Adobe Docs Express add-on samples GitHub repository. We have to get the code from that. So click this green button and copy the URL to the clipboard. Switch to the terminal. And by the way, I'm on a Mac, although I have a Windows wallpaper because it's nice. Come on, it is. And CD into the desktop. On Windows, you would use the dir command. Now, from this point onwards, every command that I write is going to work for both platforms. Okay, now let's git clone and paste the URL. This is going to bring in the files on your system, and here they are on the desktop. Let me get to the folder and let's open the files with whatever code editor you fancy the most. In my case, it's going to be Visual Studio Code. Let's get to the Document Sandbox Samples folder, and here you're going to see the Express Grids add-on. Actually, in this folder, there are two different projects. One is the starting point and the other is the end point. Use the start one if you want to follow along and code with me, otherwise just run the complete add-on as I'm about to show you. Okay, let's close this welcome thing and let's pull the terminal up. Let's cd into the final add-on, so the grids design end, and now you have to npm install to download all the dependencies. This is not going to take long. Now you have to run a couple of other scripts. npm run build, which is an Adobe CLI thing that's going to build your add-on and very likely is going to bring up the sign-in form for the CLI. Enter your Adobe credentials, nothing is behind a paywall, so don't worry about that. And finally, click this link here to sign in, and then you can forget about this whole thing for at least a day or two. Next, you have to npm run start in order to serve the add-on to localhost at this port 5241. Time to open Adobe Express, make sure that you have at least one document open, even a blank one, and that you are on the add-ons tab. Now let's have a look at your user settings, especially this add-on development switch here that must be set on. Okay, so let's close this and head to your add-ons tab, and down below you're going to see this add-on testing switch, which upon clicking shows the Connect to Development Server dialog. You have to understand that this add-on is not going to blow your computer up, and you can finally click the Connect button. Now, under your add-ons, the grids icon shows up. Click that, and finally the Grid Add-ons UI is going to appear in the right column. Cool! Let's now see how this works. Click the Create button, and the add-on is going to build a series of rectangular shapes that form this grid. In this case, it's 4 rows and 6 columns. The Delete button clears them up, and then you can change the number of rows and columns and create again, and the change is reflected on the page. Let's delete them once more and play with the gutter, which is the distance between the rectangles. You can also change the color of the shapes independently, but don't pick something too bright. Okay, so we've seen the end result. Let's delete that and get back to Visual Studio Code. We're going to build this almost from scratch. So let's stop the current process with Ctrl-C on the terminal and let's cd into the starting point. The grids design start. Using drag and drop is so convenient. And we have to repeat the whole process again. First, npm install to bring in the dependencies, and then npm run build to build the add-on, and finally npm run start, which is going to serve the add-on to the same localhost 5241. And when we get back to Adobe Express, there might be some problems. In this case, the connection was temporarily lost, but no worries, just click the refresh button and everything's going to be fine again. So let's click the Grids add-on icon, and this is your starting point. Very bare, just a button. Before going any further, I would like to discuss the project's folder structure. So let's open the Grids Design Start folder, and there is a lot of content in there. First file that I would like to mention is this webpack.config.js that we're not going to open, and this is used by the CLI to pack everything that is inside the source folder, which is where we're going to develop, and flatten all the dependencies and put everything that results into the dist folder, which is what is used by the CLI to serve the add-ons content. Next up, let me expand this UI folder. There are two files of interest here, the index.html and the styles.css. These are used to build the add-ons UI, the user interface, as well as the index.js that sits inside the UI folder that takes care of the UI's logic, stuff like event handling, what happens when the user clicks a button, for instance. The Document Sandbox folder contains this code.js file that is going to hold all the Adobe Express Document API code used to manipulate the document, create shapes, move them around, group them, change their color, and everything else. Actually, if you look at the manifest.json file in the entry points array for the Document Sandbox, code.js is set as the entry point. And mind you, it is not this code.js file here, but the one inside dist, this one. This is also the reason why there is no Document Sandbox string prepended to the code.js path. Finally, there are these tsconfig.json files, there are 3 of them, and 2 .d.ts files. These are TypeScript settings and type definition files. This is a pure JavaScript project. We're not going to use TypeScript ourselves, but Visual Studio Code is going to make use of those files for type checks and IntelliSense purposes. So let me show you an example. Let's open this code.js file. We have imported whatever this runtime constant, and when you type runtime and then type dot, Visual Studio Code knows which properties are available and it's going to suggest them to you, which is quite convenient. Okay, to recap, we have the user interface files, index.html and JS and styles.css, and the Adobe Express Document API files inside the Document Sandbox folder. Now, these two entities must find a way to communicate with each other, and how this is done is exactly what we're going to discuss next. In add-on development, any code that refers to this is part of the so-called iframe UI, whereas code that deals with the document, as was just seen, is part of the Document Sandbox, and the technology that bridges the two is called the Communication API. So why iframe? Well, if you right-click here exactly in the add-ons icon and you select Inspect, this is going to bring up the Chrome Developer Tools or whatever dev tools that the browser that you're using features. And in there are the usual tabs, the elements, the console. This is exactly what people use to debug add-ons. And if in the elements you point to the only button the add-on has, and you scroll up, eventually you're going to find an actual iframe element. And the fact that the add-on is served through this iframe protects the host application, Adobe Express, and prevents the add-on from running potentially malicious code. On the other hand, the Document API code runs inside a JavaScript sandbox because the same security concerns apply, and neither the UI nor the document-related code should be able to mess up with the rest of the system. Okay, so let's tackle this Communication API thing. Back to the code, let me open the index.js and the code.js files, and let's start with the latter. So what happens in there? We import this add-on sandbox SDK here, and we destructure the runtime from the instance. Then there is the start function that is executed right away, and the only thing that this start function does is to run the expose API method of the runtime. So this takes an object as a parameter, and this object is what is going to be exposed to the other side, to the iframe UI, which in turn is going to be able to call all the methods inside it. In this case, we only have one log function that is going to take some arguments and console log them. So through the runtime, we're going to expose methods that the iframe UI will be able to invoke. So let's switch to the index.js and see what's going on there. We have a bunch of imports for the Spectrum web components that we're not really interested into at the moment. And here we import the add-on UI SDK from this long URL. And when the add-on UI SDK is ready, only then we do some housekeeping. We store a reference for the button because we're going to enable it at the end. It starts as disable, and this is a good practice, especially when you have UI elements which behavior depends on the code that must be run from the Document API. So in this case, we must be sure that this part of the code is completed before enabling the button. And so what's going on here? We destructure the runtime constant from the add-on UI instance, and through the API proxy function, we get a proxy for the object exposed on the other side. In this case, we were passing the Document Sandbox string. This is not something that you can change. There's a tutorial on the Adobe Developer website that digs all the details. At this point, the Sandbox proxy object contains this log function that was exposed there. Does that make sense? I hope so. TLDR, we have seen how Document Sandbox code can be invoked from the iframe. That is to say, through a proxy object exposed with the runtime expose API function and imported, so to speak, with the runtime API proxy function. And now it's time to start writing some code. While we are in index.js, we want to add an event listener for the button, so when the user clicks it, at least something happens. For instance, it would be nice if a rectangle was created. So on click, we have an async callback, and for the time being, let's just console log something and see if it works. Let's check that real quick. Open the console, and with Command K, you can clear it from all the garbage. And let's click the button, and it works. At this point, we can link to the onClick handler of the createShape button an actual function in the Document Sandbox, and at the moment we only have the log in code.js, so let's create a new one aptly named createShape. And let's be fancy, it's going to accept an options object containing the width and the height for the rectangle. So back to index.js, we can use the sandbox proxy object we got earlier to invoke createShape, and let's pass a width of 100 and the same height. Uniswap pixels, by the way. Now let's get back to code.js to implement the body of this function. But wait, how do you create a shape? Well, here are your new best friends, the references, which you can find on the Adobe Developer website, SDK references, Document Sandbox, Document APIs. We can look at the classes. And the first one that pops up is the editor, which has a create rectangle method, taking no arguments and returning a rectangle node. But first we need to import the editor, and that's named import from the Express Document SDK, and we want to bring in also the color utils and the constants that are going to be useful later on. So let's store the reference for this node into a const rect equals to editor create rectangle. Let's set a width and the height, which you can do and really have to do after creation. And let's translate to a position in the page, which is whatever, 50 pixels on the X and Y axis. That was pretty straightforward. To fill the rectangle with color, we need to do some more work. First, let's define a color using the color utils from RGB function. And please note that the values are in the 0 to 1 range, so floating point, not the usual 0 to 255 8-bit values. And then we have color. We can turn this into a fill color through the editor make color fill function and pass the color. Now at this point we can assign that to the fill property of the rect, and all these properties, the width, the height, and the fill, you can find them in the reference for the rectangle node. Here they are. Okay, we have created a rectangle, but it's not rendered on the page unless we put it there. And this is a process that might appear a bit convoluted at first, so please bear with me. We must write editor, context, insertion parent, children, append, and we finally pass the rect. Like any scripting code, this is easier if read backward. So we append the rectangle object to the children list of the insertion parent, which is the best / more convenient parent to house this new content. It's a property of the editor class that points to the parent of the currently selected node. Said in different terms, we are adding a rectangle as a sibling of whatever happens to be the active and selected node at the moment. And if there's none, like on a blank page, then the page itself is going to be the rectangle's parent. So let's test our code and hopefully a shape will be rendered. The code, by the way, is automatically reloaded each time. I've hidden the terminal, but you can bring it back up and you can see the process and also spot compilation errors in case they happen. So back to Adobe Express, let's click the Create Shape and sure, here it is. So now we know how to insert a rectangle, setting its properties, width, height, translation, and fill, baby steps, but in the right direction. Now that we have the knowledge required to create one rectangle, it shouldn't be too hard to create as many as we need. But first, let's tackle the user interface. And for that, we're going to need a number of Spectrum web components, which must be imported first. Please note that they have already been installed, so if you look in the packet.json, you can find them in the dependencies object. You basically have to npm install every Spectrum web component that you need. You can find specific instructions in the Spectrum Web Components website or in the written version of this tutorial. Import statements must go into the index.js file that, as you remember, deals with the user interface, and we will need the Spectrum button, the Spectrum button group, a field label, a number field, a slider, and a swatch. The UI is made with these Spectrum web components. The written tutorial covers it in more detail, and this video is already quite long, so let me put the UI together real quick and then we'll focus on the Document API code. The layout is based on the Flexbox, so just a bunch of divs. The CTA, the call to action buttons, are in the bottom row. On top we have a number field, its label, and the color swatch, with the addition of a standard input element, which we'll keep hidden. It's used only to pop up the browser's native color picker. That's for the rows and same for the columns. Below that, we've got the gutter slider, which comes by default with its own field, and that's about it. The index.html is only the skeleton, though the logic and the functionality are implemented in index.js, which we'll look at with less hurry. Now I want to initialize all the values in the UI, so let's get elements by ID, the rows, the columns, and gutter. I would like to assign to the rows input a value of 4, to the calls input a value of 6, and to the gutter slider a value of 10. We'll do the color pickers later because they are a little bit more complicated. Let's focus on the call to action buttons now. I plan for the Document Sandbox to expose just two functions, an add grid and a delete grid. So let's start with the latter. We can store both buttons into constants because we'll need to toggle their disable state, and for the delete grid button on click event, the handler is an async function. Let's call the sandbox proxy delete grid function, which we'll implement later on in code.js. And mind you, for the communication API, these calls are asynchronous, so we must await or deal with the promise using then. When the grid's being deleted, it makes no sense to keep the button enabled, so let me set the disabled attribute to true. For the create grid button on click event, we need an async handler where we await for the sandbox proxy add grid function, the second function that we'll need to implement. And instead of passing a bunch of loose values, I really prefer to make use of an options object, again, which props such as columns, rows, gutter, column color, and row color. And for the columns, let's pass the calls input value, for the rows input value, and same for the gutter. We'll get to the colors in a minute. Now that we have created a grid, we must remember to re-enable the delete grid button, okay? So this leaves us with the color pickers business. If you remember, in the index.html, we've got two Spectrum swatch elements, rows color swatch and calls color swatch, as well as two inputs, the rows color picker and the calls color picker. So let me get them by ID, two constants for the columns and two for the rows, and let's initialize them with a color. For the color picker, we must target the value attribute, and let's pass this hex string, while for the color swatch, we must target the color attribute and pass the same string. Same for the other two. Now the trick here is that we want to add an event listener for the click event of the color swatch, which in turn triggers the click event for the hidden color picker. This results in the native browser's color picker to appear, as the spectrum swatch is just a patch of color with no picker functionality. When the user then selects a color through that picker, we want the swatch to reflect the change. So for the color picker's input event, we must find which color has been selected, that is to say the event.target.value, because we've seen a color picker has a value attribute, and then set that to the color swatch color attribute. Does that make sense? We're basically using the swatch just as a decoy to lure users into clicking it, but the click listener triggers the hidden input element's click handler, which pops up the picker regardless of whether the input was hidden or not in the first place. And then on color change, so on the color picker's input event, we must display the new color on the swatch. So let's replicate this for both, and that's about it. Oh, and let's not forget to pass the two color picker values in the add-grid options object. Okay, so at this point it makes sense to switch to code.js and implement an add-grid method, which accepts an object with rows, columns, gutter, column color, and row color props. And for the time being, let's just console log them. In a delete grid, which again, for the moment is only logging a message to the console. Okay, let's see if that works. Let's get back to Adobe Express, open the console, and I'm going to click the Create button to inspect whether the default values are passed, and this is the message logged. Let's click the Delete and check the log, that's fine. Let me modify the rows, columns, gutter, and say just one, actually both colors, and let's click Create again. Okay, so the UI has been wired correctly. The index.js is taking care of the logic, collecting the values from the UI and sending the right calls to code.js. At this point, we must implement the two missing functions, add-grid and delete-grid. The first order of business is to know on which page to add the grid. There is no current page property available in Adobe Express, at least now, so we must get a hold of the currently selected node via the editor context insertion parent that we have already seen earlier, and then we must loop checking the current node, actually its type, against this constant, which refers to the page type internal value. And if the type is right, we're fine, we can assign the current node to the page variable, otherwise we keep looking at the node's parent. So this is enough to get to the current page. Now let's start adding rows, which are nothing but rectangles as wide as the page, but how tall? Well, it depends on their number. In addition, you must take into account the space in between them, plus the ones acting as margins at the top and bottom of the page. So if you have 2 rows, you're going to end with 3 spaces or gutters, one above the rectangles, one in between, and then one below. With 3 rows, you get 4 spaces and so on and so forth. The formula to calculate the row height is the total page height minus the rows number plus 1 times the gutter. All this is divided by the rows number. Let's keep that in mind. We're going to store those rectangles into a rows rect array. And for each one that the UI requests, we invoke the editor createRectangle method, set the r-width equal to the page width, the height to the row height that we have just calculated, and then we can move it in place using the translation property. The x is always 0 because a row always starts from the left border, and the y is calculated by adding an initial gutter for the top margin plus the gutter, and then the row height times I. For the first row, this is going to be just the gutter, because I is going to be 0, and from the second rectangle onward, both gutter and rectangle height are appropriately taken into account. Now we can push the newly created rectangles into the rows rect array, and finally, when the process is completed, we can loop and append each rectangle to the first item in the page's artboard collection, so in the first artboard. Mind you, not directly to the artboard, but to its children list. Always append to the container's children property. And that is what eventually displays them on the page. Let's check that real quick on Adobe Express. And here you have your rows. Columns work exactly the same, although you must fix the formula to calculate their width using the page width and the number of columns, and also the translation X and Y must be adapted. Let's get back to Adobe Express and check, and sure enough, well, you have something that resembles to a grid, sort of. It's all black by default. It's not as nice as it should be, but this is the main structure. In the next and final part, we're going to implement colors, groups, blending modes, and refactor the code in a better and more reusable way. Okay, our grid creation is performed in 2 steps, one for the rows and one for the columns. It makes sense to abstract them into 2 separate functions, say add rows and add columns, and let add grid invoke them. I would also like to move them out of the way into a separate module so that code.js only contains the functions that are exposed to the iframe UI via proxy, that is to say add grid and delete grid. Everything else should belong to and be imported from the module. Conveniently, we already have this shapeutils.js file, so let's use it. Let me add a placeholder for an add rows function, which expects rows number, gutter, and color. And since we are dealing with only 3 parameters, there's no need for an options object, in my opinion. We're going to have a similar add columns, and we must eventually export them. For this grid business, we're also creating rectangles a lot, so it's sensible to implement a rectangle factory function right here in shapeutils where we need it. It's going to accept a width, a height, and also color, because who wants a black and white grid? This function just creates a rectangle, sets dimensions, same as we've seen before. And for the color, we first need to create an instance of the color class using color utils from hex function, passing the hex string. If you remember, this is what we got from the picker. This is now a proper color, but not a color fill. We've seen that before. To get one, we need the editor make color fill method and pass the color. And then finally, we can assign that to the rectangle fill property and return the rectangle. As this function is used just in this file, there's no need to export it. It's private to the module. Now let me grab the code we wrote for the rows and columns in code.js and rearrange it here so it fits. Just minor tweaks. We must replace rows with rows number, get rid of the editor create rectangle, and use our create rect. Similar changes for the add columns function. Let's not forget to import both add rows and add columns in code.js, delete all the code we've moved there, and invoke them passing the relevant parameters, row color and column color included. At this point, all should work. Let me test that on Adobe Express, and bingo, we've got the grid in Technicolor. And if you don't know what that means, it's how they built grids in the past century. Anyway, let's tidy up all these layers here. I would really like to have them grouped. So back to Visual Studio Code, in add rows I want to create a group via the editor create group method, and let's append that to the page and the rectangles to the group's children using the spread operators on the rows array. Another thing, we may want to play with the group's opacity so that we have some degree of transparency and see both rows and columns at the same time when they overlap. But I find using blending modes to be better, or at least that's what I prefer. So let me assign to the blend mode property the constants blend mode multiply. You can find all the available constants, guess where, in the reference documentation. And finally, let's return this group and implement the same steps for the add columns function. Now back in code.js in add grid, I don't want to just invoke add rows and add columns. Since they both return a group now, let me store them into constants because I want to add a parent outer group that wraps them both. So let me create a group, append it to the page, and append row group and column group into it. Very last step, to prevent the user from accidentally shifting the grid around, I'm going to lock the group. Let's test this real quick in Adobe Express, and now you see the blending mode in place doing its job, which is nice. And here is the outer locked group with its inner content. Okay, fine, just one last bit missing, the delete grid button. And from a practical standpoint, removing the grid group would be enough to make its content disappear. But how do you refer to such a group within the delete grid function? Well, the trick is to have a global variable, let's call this gridRef, which starts as null, and inside the add-grid function, as the last step, we can assign the grid group to it. Now, the delete group can attempt to remove it because the JavaScript context is persistent between calls from the iframe UI to the Document Sandbox and vice versa. So gridRef is sticky, so to speak, until you have a new session anyway. If the grid reference is not null, then we can try to remove that, and it's wise to have a try-catch block here because a lot of things can go wrong. We can use the remove from parent method, and don't forget to set the gridRef variable to null again. And if something does indeed go wrong, let's log an error message to the console and return an error string. One final jump to Adobe Express to test this. Let's create a grid. Let me try to delete it, and that works too. Let me pop the console up, just in case there are any errors, but we're lucky. Let's also modify the parameters and create a different grid. Let's delete it once more, and that's it, the final version of the grid add-on. There are many ways to improve it, though, if you want to put yourself to the test, which I encourage you to do. For instance, you can have a separate control for the page margins. We currently use the same gutter, but exposing them to the UI could be nice indeed. Or if you don't want to use blending modes, you could add an opacity slider, maybe also add a switch that toggles the grid on and off instead of deleting it. And for the very posh add-on, why not adding a drop-down menu with a series of presets to store the most commonly used grids with the possibility to select, add, and delete them? Client Storage API could be handy in that case. Just a few suggestions, and if you implement them, please share the results with the community. Hey there, hope you've liked it and learned something new. In the video description, you can find all the links to the official documentation, as well as the Adobe Express Discord server that features a channel dedicated to add-on developers. Thanks for watching. Bye.